Chapter 3, Probability. Look at all those sections. Don't freak out. As stated in the Chapter 2 opener, some of these sections will make their way until the Chapter 2, so we won't have a 11 section test. That'd be terrible. Anywho, let's go through all the sections. 3.1, Probability Basics. You get the idea of the three ways to present a probability answer as a fraction, a decimal, or a percent, the fraction being the most important one, and also discusses basically what happens in the numerator and denominator. In section 3.2, we learn about OR and what the OR does to the problem. You'll learn, as an overview, that OR generally means to add, but sometimes it could also mean to subtract, so be careful with that one. Then in section 3.3, probability including not, you'll learn that not means, well, not. So, for instance, if the chance of rain is 40%, the chance of not raining is 60%. If you get that idea, that's the entire section. You'll also see how not can be useful for more difficult problems. In section 3.4, the fundamental counting principle, this concept we see a couple more times in how we learn how to count. I know it sounds very weird, but it's going to be very, very important. You start to learn about this magical word and how and affects the problem. In section 3.5, conditional probability, this is where instead of thinking about the entire amount of possibilities, I don't want to say the term just yet because I don't want to scare you. You only think about those possibilities under certain conditions. So, for example, instead of asking the question, what's the probability of picking a heart? The question will change to, what's the probability of picking a heart given you've picked a red card? So you'll learn in conditional probability, the key word is the word given. 3.6, we learn about permutations and combinations. And this goes back to 3.4, actually. A permutation, you'll find out, is an ordered arrangement of distinct objects, and a combination is an unordered arrangement of distinct objects. So we'll tackle problems of those types and then also relate it back to 3.4. And then 3.7, probabilities with permutations and combinations, is a combination of sections 3.1 and 3.6. It all comes together. And then in 3.8, binomial probability, as the name implies, bi means two. In a binomial probability, you only have two options. And there's actually four conditions for a binomial probability. One of them is you only have two options. And we'll discuss about the other three. And then we'll talk about the pitfalls students have in possibly confusing a binomial probability with things that are not binomial probabilities. So watch out for those. Section 3.9 and 3.10 are related. They discuss the standard normal distribution. You may have heard of a normal distribution, which is a technical term. You may have heard of its informal name called the bell curve. So if you've ever studied heights of students, for examples, because I know you've done that. You woke up this morning and I'm like, I want to study heights of students. Perfect. Then you'll notice that if you had enough people in the room, you'll notice that few of them are below average. Most of them have average height, and some of them have above average height. So if you were to plot that out, it looks like a bell. Hence why it's called the bell curve. So in these two sections, you learn about predicting probabilities that a person is within, going back to the height example, just making these numbers up, 55 inches to 62 inches. What's the probability that someone in the room has that height or is between that height? That's what those two sections deal with. It is also the start of the concept of a distribution, which will carry on into stats. And lastly, expected value. Well, if you recall that in the Chapter 1 overview, I discussed average daily balance. Well, expected value is the second iteration of the average daily balance. And basically it says if you played an event over and over and over again, what's the expected value of doing that event? So the one that's a little more tangible is if you entered a raffle every time, then what's the expected value of your ticket? If that's a positive number, that means you're expected to win. And if it's a negative number, you're expected to lose. And if you can guess from a raffle, are you expected to win? Nope, unless it's rigged, and that's bad. But that's chapter 3, probability.